RC time constant. Here one digital voltmeter is provided, that range is 20 volts it read, but the power supply is only 10 volts. Okay, 10 volts DC power supply is given. Charging discharging switch is also given. A reset button for discharging capacitance is also given. 1 2 3 4 5 6 7 combinations of resistance, that is from 2.2 to 560 kilo ohms. Okay, and 1 2 3 4 5 different combinations of capacitance, that is 3300 microfarad, 2200, like 47 microfarad. Okay, so now, and also a stop clock for calculating RC time constant is also provided with this kit. So this is start, stop, reset, start, stop, reset. Okay, so this is the connection. Power supply positive is given to switch to resistance, resistance to capacitance, capacitance to power supply. This is 10 volts, we are providing 10 volts only. So across this voltmeter is connected. So I am doing the connection, positive of the supply to resistance. Now I am taking 10 kilo ohm resistance here and 3300 microfarad capacitance. Sorry, positive of the connection, positive supply to charging switch, switch to resistance, resistance to capacitor, capacitor to power supply negative. Okay, now across capacitor I am connecting voltmeter. Okay, across capacitor I am also connecting a reset to reset the any charge left over in capacitance, like this. There is already some voltage is there in capacitance, that is 0.05 volts. By pressing this we can reset it to 0. Okay, so connection has been done. Power supply positive to switch, switch to resistance, resistance to capacitance, capacitance negative is given to negative the power supply. Across capacitance we are connecting voltmeter. Similar connection has been done on the board. This is the stopwatch. There is a switch provided here for charging, discharging. Right now I am doing charging. So as soon as I charge it, I will start the stopwatch. So stopwatch done. So for every 5 seconds you have to note on the reading. 1.83. For 10 seconds it is 3.20. 15 seconds it is 4.09. 20 seconds 4.89. 25 5.56. 30 6.20. 35 6.73. 40 7.08. 45 7.56. Like that you have to take down the readings in the tabular form with every 5 interval. We have taken 5 interval times. You can even take 2 interval as per your convenience. You have to note down the readings here. As soon as it reaches the maximum, in this board it is maximum power supply is given 10 volts, that will reach around 9.2. As soon as it reaches the VS, you have to shift the switch to discharging. So you have to note down like this all the switches. 1.15, 1 minute 15 seconds is 8.88. 1.20 8.98. 9. 1.25 9.9. 1.30 9.09. 1.35 9.15. 1.40 9.19. That is the maximum voltage we have reached. So again we have to reset and discharging. Similarly we have to note down the readings for discharging as well. It is the same interval of 5 seconds, 7.50. 10 seconds 6.439. 15 seconds 5.70. 20 seconds 4.67. 25 4 30 3.42 35 2.88 40 2.40 45 2.03 50 1.78 55 1.59 60, that is 1 minute, 1.22 1.05 1.09 1.110, that is 0.90 1.15 0.76 1.20 0.69. Like that we have to note down the readings in similarly in this case here discharging. For every 5-5 interval you have to note down the readings. So now we got the readings for charging and discharging. We can draw the graph in between time constant like t and this is voltage. So t is nothing but this stopwatch t time taken, and this is the voltage we have noted down from the here. So charging and discharging we can note down. Even in the calculation part, see here, R we have chosen is 10 kilo ohms, capacitance is 3300 microfarad. So time will be 33 seconds. So what will be the value of the voltage across the capacitor at 0.7? You can see 0.7 T is nothing but Vc is equal to 0.5 Vs. Therefore Vc is equal to 0.5 into 9.2 voltage. 9.2 is our source, that is Vmax here, 9.2 voltage we have taken. So that will be voltage across the capacitor will be 4.6 volts. Similarly for 1 time seconds it will be 5.79. For the value of the voltage across the capacitor for 1 time second discharging will be 3.13 volts, charging and discharging. So charging Vc is equal to 0.63 Vs, right, for charging. So 0.63 into Vs. For discharging Vc is equal to 0.37 Vs. So 0.37 into 9.2. So this will be the thing. So how long the capacitor will take for charging? 5 times seconds. That is nothing but 5 into 33. That is 165 seconds. So that is already we have proved it out. 60 seconds. It is clearly done. Okay.